So the rest of the problems in this file are going to focus on, if I have two triangles, how do I tell if they're similar or not? So how do I look at two triangles and be like, okay, yeah, these are similar, these are not similar, because that's something that gets asked quite often on exams as kind of an introductory level of question to one of these things. There's two triangles, you'll know some information about them, and they'll say, hey, are these two things similar? All right, so we did this a little bit with congruent earlier in the year. Now we're going to talk about it with similar. The most basic way is if you have two pair of angles that are the same. All right, so two pair of angles that are congruent. You could have three pairs, but you only need two. You have two pairs of angles that you can say are congruent. They have to be similar. All right, doesn't matter what the sides look like. We're just looking for two pairs of angles. You will often have to find a missing angle. All right, so if I know these two, earlier in the year we found a missing angle, and then we talked about what it was. So we might have to do that because we might know two of the angles, but need that other angle to be able to answer the question. So keep that in mind. Angle is the most common way to show that triangles are similar. There is also side, side, side. All right, now side, side, side means that you're going to take the triangles. You have to know the sides first of all. So if you don't know the measurement of the sides, then this is out. You cannot use this. All right, but if we know the lengths of the sides, then we can take the sides and we can set up ratios. So you can see here that we've set up 3 ratios, and we see if they're all the same. All right, now how to do that? You would divide them to see if they come out to be the same. Each of these would be 0.5, so that'd be 0.5, that'd be 0.5, and that would be also be 0.5. Okay, since those are all the same, the triangles have to be similar because they have this common scale factor. All right, but the real thing that you would say, you could just say side, 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 or you could say common scale factor. All right, the one thing to pay attention to is you have to make sure that you're comparing the sides in an intelligent way. So 16 is the smallest side of that little triangle. It wouldn't make any sense to compare it to 44 because that's not the smallest side of that triangle. We would compare the 32 because that's the smallest side of that triangle. Likewise, we would compare the 25, which is the largest side, to the 50, which is the largest side. And then the 22 would go along with the 44. So make sure you do it in a way that makes sense. The least common way, but it will get mixed into multiple choice questions, is side angle side. Now this one's a little bit confusing when you first think about it. All right, the angle, remember, is in the middle here. So it means there's a pair of sides and then a pair of sides, and there's a pair of angles in the middle that are the same. All right, if you look at this picture, what we have is we have an 80 here and an 80 here. Okay, and then we know the measurements of the 4 and the 8, and I put those two in blue because they're the bigger sides, and the 3 and the 6. So if those two pair of sides have a common scale factor when I set their fractions up, because the angle in between them is the same, then those triangles will have to be similar. So you would set the scale factors up, and it doesn't matter if you do small over large or large over small. I typically always set small over large. So I get 1/2 or 0.5 for each of those. So they have a common scale factor. They have the angle between them the same. So it's side angle side. All right, make sure you compare the largest side to the largest side and the smallest to the smallest. All right, so any of these questions here that say, hey, are these triangles similar? We're going to check the angles first if we can. If we can't, we're going to check the scale factors and just look for side, side, side. And the least likely scenario is we have to check for an angle, all right, and then see if the scale factors are the same around it. And it's possible that the answer is no. So don't automatically think that the answer has to be